Okay, let's solve a couple of inequalities, and the first thing I want you to do is just kind of pretend that that greater than or less than sign isn't there. Okay, let's just pretend that this says equals and use our own normal algebra to rearrange and get x by itself. Okay, so let's just walk our way through this. I take 4 and I add it to the other side, then I get 3x and I get 15. Then I divide by 3, and I get x is greater than 5. Okay? Now this is the way you're going to do all these problems. The only time that greater than or less than sign is ever going to change is if this number that's attached to the x is negative. Okay? If I have to divide by a negative value, then that less than or greater than sign has to change. And we'll go through in class why that is, why we have to do that to keep the meaning consistent. But in this case, I got x is greater than 5. Well, how many numbers are greater than 5? 6, 7, 8, 9. They go on forever. There's an infinite amount of answers to this. And so I want to make sure that I don't have to write them all out. What I'm going to do is I'm going to just draw a number line and show these answers instead of writing every single one of them out. So I'm going to start by looking at this number 5. Say, okay, that was my boundary, so I'm going to just put 5 right here. 6, 7, 4, 3. I just write some numbers that are close to 5. And now, what's a number that's bigger than 5? Well, 6, 7, and so on. It's all of these values right here that keep on going this direction. The question is 5 a number that fits right there? If I put 5 in, is 5 greater than 5? No, it's not. But 5.1 is. So I'm going to leave this circle open. I'm not going to color it in, because if I color it in, I'm saying 5 is a solution to this. And 5 is the boundary. But in this case, it doesn't actually work in the statement. And this is how I show my answers. This tells me with this little arrow here that they keep going forever in the positive direction. Now, what if I get what's called a compound inequality? I mean, I got more than one comparison happening at the same time. Well, it's like I have two equal signs, which is kind of weird. But I'm just going to take my normal algebra and apply it. I'm going to subtract 1. But since I subtracted it from the right side, I'm also going to subtract it from the left side. And I cross it out, and I end up with 2x is less than 4, and is greater than negative 4. Okay, now I'm going to divide by 2 on every single piece, every side. And I get x, and on this side I get negative 2, and on this side I get positive 2. Now, do I need to switch the inequalities? Do I need to flip them? I look back at the process, and when I did my division, did I divide by a negative number? No. So everything stays the same. Now what I need to do is I need to make sense of this and put it on a picture, because that right there doesn't always mean a lot to people. You need to be able to draw it out so you can represent its meaning. Okay, so I'm going to just start and put 0, 1, 2, 3, there we go, negative 1, negative 2, negative 3. Okay, so I got my number line there. Now, let's just look at one piece of this. Okay, let's go back and let's take a look at this portion right here. This says x is a number that's bigger than negative 2. Well, what's bigger than negative 2? And remember, bigger means more positive than negative 2. Well, how about negative 1, 0, and so on. Okay? So I've got numbers that are bigger than negative 2 going this way. But then it also says I need numbers that are smaller than positive 2. So look at positive 2 over here. Well, I want numbers that are smaller than that. And notice they meet in the middle. So my solution set is all the numbers. And by the way, there's an infinite amount of them, because remember, they can be decimals or fractions. All the numbers that lie between negative 2 and positive 2. Those would all work as a correct value to put right there. Now, some of you are going to say, well, when do we shade things in? I don't get that part. Well, look here. If I ever see this, so let's say this was less than, but then there was an equal to portion there. That means it could be equal to -2. I would do this. Okay? I don't see that in my original problem, but if this was here, then that means I've got a circle that's shaded in. And we just apply that principle to everything like this.